Alright, when we talk about like radicals, it's very similar to like terms in the sense that if you had something like 4x and 3x, you could consider those like terms. So if you did 4x plus 3x, you could just add those together to be 7x. Like radicals are very similar to that in that if your radicals are the same, you can add the numbers in front. So in this example right here, you have the square root of 2 plus 3 square roots of 2, and you just add 1 plus 3 will give you 4, and you leave the square root of 2 as it is, so 4 square roots of 2. Same thing if you have the cube root of 7 minus, now on this one here though, you would just do 1 minus 5 to get negative 4 times the cube root of 7, and so on. So these ones down here, you can simplify this because they have the same radical. You have like radicals, so you just take 3 minus 2, which gives you 1 square root of 5x, or you could just write that as the square root of 5x. This one here, we have a cubed root in this one, but we have a fifth root here. So from that, you are not able to add them together or subtract them because they are not like radicals. Same thing with this one, that these are not like radicals, so there's nothing you can do. You have the square root of 7 and the square root of 5, which are obviously different. So in these ones here, you could either say can't be simplified, or you could just rewrite the same thing. Either way would work. Now here we do have the square root of xy and the square root of xy, which means we have like radicals and we can add these together. So 3x plus 7x would give us, 3x plus 4x would give us 7x, and you'd have the square root of xy on there at the end. Notice again when you add these together, the radical stays the exact same. You don't make it 2 or anything like that. You leave it as the square root of xy. Okay, in this one, in the stained glass window design, the side of each small square is 5 inches. Find the perimeter of the window to the nearest tenth of an inch. So what we have to do is we know that this right here is 5 inches, which means this is 5 inches, this is 5 inches, this is 5 inches, and so on. Okay, and that's true for all of them all the way along. All the sides are all 5. So we know here that these two sides are 5, and we want to figure out what this side is. Okay, so if we redraw that, we're going to have 5, 5, and we'll call this x for now because we don't know what it is. Now, we also know that the shape of these is a square, which tells us that this is a right angle. And when we have a right angle, it means we have a right triangle, so we can use the Pythagorean theorem. Remember that C is always the side that is across from the right angle. So in this case here, it's going to be our x that we have over here. So when we do this, we'll have 5 squared plus 5 squared equals x squared. So you get 25 plus 25 equals x squared. 50 equals x squared, square root of both sides, and you end up with x equals square root of 25 times the square root of 2, which gives us 5 square roots of 2, and that is equal to x. Okay, now what that has found for us is it's found this side right here. That side is 5 square roots of 2. Now from that, if we just notice here though, that we have, this is 5 square roots of 2, this is 5 square roots of 2, same with this, 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 and all the way around. And so we end up with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them. So what we want to do is we really want to add this up 10 times. So 5 square roots of 2 plus 5 square roots of 2 plus 5 square roots of 2 and so on. Or the easier way to do that would just be to do 10 times 5 square roots of 2, which ends up giving you 50 square roots of 2. And we want to put a label on it, okay, and we know from the problem that that is inches would be our units that goes along with that. The next section then deals with simplifying before adding or subtracting. When you do this, we just want to think of each of these radicals as a separate problem to start with. So the square root of 12 we can simplify into the square root of 4, square root of 3, which gives us 2 square roots of 3. It remains plus, but then the square root of 75 is square root of 25, square root of 3, which becomes plus 5 square roots of 3, and then minus the square root of 3, that just stays as it is. And then here now we can do 2 square roots of 3 plus 5 square roots of 3, which gives us 7 square roots of 3 minus 1. Okay, and you end up with 6 square roots of 3. Notice when we do this so that we keep everything in a line horizontally and vertically, that we want to make sure that this is still the same as this. We've just manipulated it a little bit as we go. This other one then, now we have cubed roots. Okay, so cubed root of 250, what multiplies the 250 that we know the cubed root of? Remember, those numbers are 8, 27, 64, 125. So this one would be the cubed root of 125 times the cubed root of 2. This one would be the cubed root of 27, cubed root of 2. And then this one would be the cubed root of 8, cubed root of 2. This is subtraction, this is addition, just like we had up above. And when you simplify everything you can in here, you end up with 5 cubed roots of 2 plus 3 cubed roots of 2 minus 2 cubed roots of 2. And when you combine this, 5 plus 3 is 8, minus 2 gives us 6 cubed roots of 2. You do have to be careful to make sure that all these end up being like radicals. If, for example, this had been a 5 here, okay, you wouldn't have been able to combine that. You would have combined the 2 you could, and then not subtracted that off. You would have just left that, but because they were all the same, that allowed us to add them together.